I'm Chetan Shivashankar. I'm the Kubernetes tech lead at Percona, and Mr. Daniel.
Daniel Guzman Burgos, I'm PMM tech lead at Percona.
In today's world, there's a lot of focus of running applications on a immutable way, right? Like where you try to run the application and you also run the infrastructure in an immutable way. And container is a very good candidate for it because it's lightweight and also it's portable. And when you're talking about containers, especially at the scale, Kubernetes is kind of a de facto environment for running all the containerized applications. As you're running more and more applications, and also nowadays more and more databases on Kubernetes, it's important to have your Kubernetes cluster healthy, because the health of Kubernetes clusters will definitely affect the application health, and also if you're running databases, it will be affected. DGB?
So to bring the topic to the database ecosystem, it's just a refresher on how it might look like a database running on the Kubernetes. So Kubernetes at the end is just a container orchestrator, right? So databases will run on containers. This is a very, very basic example of MySQL regular async replication, where you can have 3 nodes, which in this case it will run, well, actually n nodes, but 3 on the graph, 1 pod per node. The pod is just an abstraction of individual unit elements that might contain one or might contain more than one containers, right? Ideally, it should be just one container, but there are some services that will require to be very tight coupled, so you can run something called a sidecar container. But let's say just a database, right? Which is actual code and utilization and the data layer, the volume. So it's pretty much like that. It's just an orchestrator of containers. So what we're going to monitor? Containers, right? So containers, resource usage. So it's going to be abstraction over something real. The real is the host or the machine. The abstraction, it's either the OS or the VM, which there will be 2 double abstraction. And then the other one, it's the pod and the container. Doesn't matter. It may be confusing, but at the end, it's just resource metrics. So here's like a better example of that, which if you go up there, it's like what the application will see, right? On the container, this is very generic for, this actually might be for stateless instead of stateful. But at the end is, we put Docker, but it could be any runner of containers, Cryo or run the Pacman or whatever. The host, that might be a VM, so other host, and the infrastructure. So the challenge is how to distinguish metrics that are related to the host as a whole and what it's actually from the container usage.
So how do we actually analyze the health of clusters, right? There are, you need to capture data. Even for us, right, if we want to see our health, we have some parameters to be checked, like maybe pressure and all those stuff, right? So similarly, it applies for Kubernetes cluster as well. So the first thing what we need to do is collect data. We need to collect some important data which can actually show us what's the health or what's the status of clusters. And how it actually happens in Kubernetes is, like maybe in any environment is, we actually capture a lot of data, right? A lot of data, and it's over time. So unless we actually store it somewhere and kind of do an aggregation or derive some kind of condense it in a good way, it will be a lot of noise. So we need to be able to capture signal out of noise. So that's why we need to store and also aggregate data. And after you aggregate data, we can derive insights. we'll see like what insights we can derive. So there are some popular, like these are some of the very popular data collectors used in Kubernetes. So the first one is CAdvisor. So CAdvisor stands for Container Advisor. So the Container Advisor captures all the metrics related to the containers. It could be the CPU used by containers, it could be memory used by containers, the network usage, or it could have some advanced statistics like, what's the number of threads being used, the inodes, and all those stuff. So basically, any metrics you're looking for containers, the CAdvisor will capture it for you. And there's Kubelet. So the Kubelet is a binary, or like it runs as a daemon on every single Kubernetes node. This actually is responsible for running all the pods on the Kubernetes cluster. So the kubelet metrics will actually expose some of the very important metrics like the pod lifecycle metrics. So the pod lifecycle metrics, what I mean is, when you run a pod, like how much time it takes to start up a pod. Or when you kill it, how much time it takes to, if there is a delay between providing instructions and the actual time for getting the pod killed. And there are so many things related to the pod lifecycle events. Everything is captured by this kubelet. And another important metrics captured by kubelet is the volume metrics. So, especially in the stateful applications, right? We need to have some sort of persistent storage. And everything, maybe for example, if you are using elastic block storage from EBS, you will have it attached as a volume in your system. In turn, the pod itself is using the EBS volumes. So all this volume details are captured by kubelet metrics. And the Kubernetes itself exposes an API called metrics API. As we know, like Kubernetes has a control plane, right? Like it's very important to monitor this control plane metrics. The control plane metrics might not be so relevant for the users who are using like like the managed control plane, like an EKS or GKE. But for a lot of people who are using Kubernetes with a self-managed control plane, right? This is extremely important. You need to keep your cluster healthy. For this, metrics API is very important. And there's kubestate metrics. We all know, right? Like Kubernetes is consisting of tons of objects. Like you have custom resources and all those stuff, like the pods, the deployments, the daemon sets, and all those stuff. So we need an exporter which actually kind of captures the state of all these objects, not just the basics ones, but all the relevant information so that we can derive how healthy are the Kubernetes objects. And then you have the node exporter. So right now, till this point, we were capturing all the stuff related to the pods and the Kubernetes object, right? But what about the actual node which runs the pods? We need to ensure that the nodes, it could be virtual machines or physical machines, we need to ensure they're healthy, right? So those metrics are being captured by the node exporter. And of course, it's impossible to get everything in one page, right? You might end up in a page where you cannot have something. So obviously you can come up with your own custom exporter. So these are some of the popular. Of course, if you are aware of anything which I've missed, I'm happy to hear it. Okay. So right now, this is the first phase where all the data collectors captures the data. And in the second phase, we send the data and we should store it, right? The second phase is the storage. So in general, in the Kubernetes world, we use something called as Prometheus, which is a very good time series database. So we capture all the data and push it into the Prometheus. And then in general, again, this is a generalization. Of course, there are a lot of different tools. So we run something called as PromQL, which is like a Prometheus query language, to kind of give an aggregated data. So a simple example, if I want to share it is, suppose I'm exposing like what's the memory usage at this point of time, but I'm sending it every single second. But if I want to know what's the memory average, memory usage over an average of 5 minutes, I need to ensure that I'm capturing data for all the 5 minutes, and I need to aggregate it. So all this is being done here. And then you have your aggregated data. So it's like you're kind of in a stage where you've got some basic signals from a huge pile of noise. So you have this aggregated data. And okay, I have this aggregated data, but what should I do with it? It's just having data, right? I need to have some actionable insights, or I need to get some information on the system. So you could get this either with alerts, or you could get with a visualization. And of course, you have data and you have you have multiple ways of how you want to derive it. But these are like a couple of common ways. And Grafana is a very good tool which can help you to get both alerts and visualization. Any questions so far? You're all good? So we have a beautiful very good tool called PMM, and DGB is the expert in it. So I'll hand over the mic to him.
So as you just saw, there's a lot of steps, right? Just to get metrics, collect them, process it, and then consuming all the stuff. Luckily, there's better ways to have all that with less effort. So PMM, very, very high level, is Percona monitoring and management tool. Under the hood is store metrics information on Victoria metrics instead of Prometheus time series database with some enhancements. And the metrics consumption is through, instead of PromQL, metrics QL, which is pretty much similar, using Grafana, right? PMM already come with some dashboards that are useful for any type of database deployment, right? So if you want to monitor your database on prem, you don't have to change anything. If your database is on VM, you don't have to change anything. If your database is on regular containers, as long as PMM can collect the data, you don't have to change anything. And that also applies to Kubernetes, right? Since we're talking Percona and we're talking databases, we're also talking about MySQL dashboards, but not only MySQL dashboards, Postgres dashboard, MongoDB dashboard. Since we have the three operators, Kubernetes operators for the three technologies, everything that is related to the layer of the database is already covered. It doesn't matter if it's Kubernetes or not. Now, this is like real stuff of Kubernetes, right? So I always say that monitoring and colors are not like related all the time. Like this is monitoring also, but it's not very straightforward or very easy to digest, right? But it's monitoring. You can see here information from a pod. This is from a PXE cluster, stuff, how many CPU is requested, memory, stuff like that. It is monitoring, yeah. It's nice, yeah, but this is better, right? Graphical. So this is not PMM, this is something else, this is called Octane. But it's the same information, but easier to understand, right? Some sort of the relationship of the pod with persistent volumes, with the service, and with secrets where that passwords are stored or sensitive information. So when you add colors to monitoring, things are nicer. So again, this is monitoring, right? This is something called top for pods that you have to install 6 metrics to get it, but pretty much it will tell you at the moment that this was executed, what is the CPU consumption and the memory consumption, right? This is very useful for see if you are allocating or asking way too much resources or way too many, whatever, but it's just an instant and you have to execute it like several times to get some idea. So why not better use grabs? Also monitoring, but also history, right? Also easy way to catch patterns of what's going on. This is actually a real PMM dashboard that it's still experimental. It's gonna be available on future releases, but it's to show the how are we going to complement all the information that we already have for the database abstraction layer, the node layer, and then things that are related to the container it's inside Kubernetes. This actually requires 3 of the 6, 7 that Chetan mentioned collectors. So to get this, we have to use kubestat metrics, advisor metrics, and kubelet, right? But the idea is that you don't have to do that. We just make it for you, ship it, and make it available for you to just use it. So that would require install and configure the data collectors, right? To make it usage on PMM server. And like I said, the idea is that you don't have to worry about that, that PMM will do all the stuff. So you want to go to the, we want to show some live stuff.
Okay. So
This works?
yep. This is a PMM home dashboard. So you have a section here called DBAS. So basically in DBAS, you have an option of adding your Kubernetes cluster. So basically, if you register your Kubernetes cluster with the PMM DBAS, you can either put your kubeconfig file here, or if you're using something like an EKS cluster, you can also, put your access key and all those stuff, so that the kubeconfig, when it is trying to invoke the AWS CLI for getting the JWT token, this actually works. So once you configure your Kubernetes cluster, you just add your Kubernetes cluster, the PMM automatically helps you for registering, installing the MySQL operator and like the MongoDB operator in this. It's getting delayed. I don't know what's the reason for it, but you should see, okay, I think this, yep. As soon as the Kubernetes cluster is, what's happening? The typical Murphy's law.
So it's, once you have the Kubernetes ready to receive a database cluster, it's just a matter of tell PMM, this is my cluster, and this is the technology, database technology that I want to use. Right now, it's only MySQL and Mongo.
That is okay.
Oh, look at that.
Yep. I'm helpless in this. I can't do anything for this. Okay. Okay. So just imagine that, as soon as the Kubernetes cluster is registered with PMM, PMM will do the automatic registration for me, like automatic steps for you, where it installs the Percona operators for MySQL and also for the MongoDB. So, okay, it's still taking time. So once you have this, what it actually also does is it installs something called as Victoria Metrics operator. So Victoria Metrics operator will is kind of like a Prometheus agent, where it captures all the relevant metrics and pushes it to the Victoria Metrics in the PMM server. So what we can actually do is, by default, at this point of moment, when you register the cluster, it will install the kubestate metrics for you. It will also capture the C advisor metrics. It will also capture the kubelet metrics for you. So this could be easily checked. For example, if I want to see like what are the metrics being captured, I can see something like this. Okay, if it starts with container, generally it's a C advisor metrics. So I can check something like container underscore CPU usage seconds. So then I can have maybe like, I can check in the default namespace, and maybe I can check for, you can also have like, okay, let's check it in for default, all the default namespace. So as you can see here, it's capturing the CPU usage seconds for all the containers in the, let me show it for, yep, all the containers in the default namespace. And if we want to actually see the kubelet metrics, it looks something like, it starts with kubelet. So is this font too short? Yeah, if you can see, right, the kubelet actually has a lot of details, like what's the pod per count, and like how much time did it took to do a graceful shutdown, and all those stuff. So you have all the relevant metrics related to pod lifecycle. And you can also see the kube state metrics, where it will see like, I need information for pods. So I'll have something like kube underscore pod. You see a ton of information, right? Like I can see the info, I can see the init container details, the start time, like pretty much everything I want. If I want to see like what's happening with the deployment, I can see here. So a lot of information is being captured here. So what I do is, like, once all this information is captured, I do run a Prometheus query for simplifying the data. And with this, I can create dashboards. So who runs Percona operators on Kubernetes? Awesome. Come on, Steve, you should raise your hand.
Which one? The MySQL. Mongo?
Awesome.
Right.
Okay. So one of the things which you might want to do is, right, like, okay, all these days we are monitoring. I mean, like, of course, you have some community dashboards. If once you have these metrics, right, it's very easy to import some community dashboards. All you need to do is go to the Grafana dashboards and, just type for Kubernetes. Okay, you see the internet? I can't help you. So yeah, you will get tons of dashboards which you can directly import it. Or once you have this, you can also customize something like this. For example, in this case, right, what we are actually doing here is, sorry. Where did the other one go? Pardon? Yeah. So here what we have actually done is, for example, I'm choosing this default namespace, and you can also see which databases are running. Right now, unfortunately, I don't have any PSMDB running on it. So, but if I had any the MongoDB cluster running on it, it would have shown like what all databases are running on it. So I have a PXE running. So as soon as I select this, it will show all the databases running on it, and it will automatically show you what all pods related to it. In this case, it's showing all the HA proxy and the PXE pods. So maybe I want to explore what's happening with the PXE0, which is like the primary one. So as soon as I see that, can see maybe it might be too small for you. It will give you a status like what's the request and what's the limits. And also it will give you an indication of what's the current usage. And also, if you want to get a memory statistics, you can also get that. So here you can see a mapping of, getting the metrics from a Kubernetes world to the database world. So this is possible when you merge both of these metrics. And for those who are running on databases, right, it's very important to, I know DBA is hearing like, okay, I cannot have my node go down, I cannot have my pod go down, right? That's one of the things. So for them, it's actually easy to monitor the container restarts. And I don't have any termination, like maybe if I see some thing over last 30 days. Yep, I'll also have the statistics. If the container got OEM killed or it's an error or completed and all those things. For those coming from database world, this might be super valuable information, right? Where they want to know when the container get killed by OEM. And the other important information, like what's the volume, what's the storage used, what's the percentage, and what's the capacity, and this also could be important, like volume usage, right? If there is any burst of data, right, it's easy to recognize it here. You can also, from this, this is one of the way. The other way is you can also create an alert where if the storage utilized is more than 80% or 90%, you can get an alert. So all these are captured. You have PVC stats and all those stuff. So this is seeing the database metrics. And if you also want to see something like a Kubernetes perspective, you can see something like this dashboard. Again, this is a community dashboards. All we did was, okay. Huh? Yeah. Okay, I'm helpless. Let's see what boards have opened so that, maybe we can go through the ones which are there. Okay, let this open. Maybe till that time, maybe DGB can walk through the database metrics, which is already open.
Yeah, the database metrics are the same. Like I mentioned before, PMM is kind of agnostic of what kind of deployment is the one that is monitoring. So if you're already familiar with how to read and make interpretations of these graphs, it's going to be the same for once you move to the Kubernetes operator. Maybe what can be new is, okay, more information on when you can see, for example, that your cluster size, and this applies also for Mongo, let's say that you lose one of the members of the replica set, you can easily go and see if it's because the pod was evicted for X or Y reason, or if it was something else, to confirm or discard stuff. But it's pretty much the same experience, independently of what kind of deployment you have.
Let's see if the board has opened. Yep, finally. This is one of the dashboards where I'm actually getting the cluster status. This is the overall cluster status. So together, accumulating all the nodes, I have 5 nodes, I have 10 namespaces, I have like 65 running pods, and I can also get a list of all the objects running on it. And it can give me like the cluster CPU utilization, okay, if there is any burst of it, memory utilization, and all those things. The network utilization, you have like tons of information. And also if you want to see like what's the usage per pods. Okay. Probably we should have taken the screenshots.
Nah, this is
yeah. So
more exciting.
Yeah. So, again, always encourage you to go to the Grafana dashboards. There are like tons of it. All you need to do is just come here into PMM and just do like an import. Once you do the import, maybe assume I want to do this. I'll take a Kubernetes cluster maybe. For every dashboard, I'll have ID. All I need to do is copy this ID and do a load. So it will show me like what are the dashboards. And if I just do import, you will get all the relevant, you see? you will get all the relevant data. So the most, okay, might need to check something, but this is how the flow works. Sorry for the internet. Yeah, I mean, how it is actually done on the real cluster is, let me show you this. Okay. Yep. I have this, whenever I register the Kubernetes cluster, right? Automatically, this Kubernetes cluster will install something like a VM operator and the monitoring system. And it will also configure some scraping agents. So the scraping agents are the one which reads the data from the services and pushes it to the Victoria Metrics server on PMM server. So if I see something like VM node scrape, I mean, VM node scrape is one of an object. It is dependent on the VM agent to capture all the, like the node relevant metrics. So if I do something like this, again, it's capturing, I mean, this is an API exposed by the Kubernetes system. It will go into each and every single node and scrape the metrics available at proxy metrics advisor. Similar for this, you can also have the kubelet metrics. And if I want to see like how the service is being, the service metrics is captured from the kubestate metrics, I can do something like a VM service scrape. So this service scrape is capturing metrics from all the services which is having this label app.kubernetesio.name with Kubernetes kubestate metrics. So I can just see like the services which is having the label of app.io.kubernetes net name. Yep. So this is how it's capturing all the metrics. So the main part is VM metric, the VM operator, which does all the magic for you. And for those who are interested in the node metrics, we also have like the node exporters. Let me try to show it for you if it's possible, if it opens. Okay, till this dashboard opens, right? Like, which monitoring tool you use for monitoring Kubernetes? You need to start that.
That's actual that one. Yeah. But if you're on EKS, you have plenty of options, especially with CloudWatch enabled, that we actually can also collect data from CloudWatch into PMM. Yeah. We're already doing for RDS databases. At the end, CloudWatch just logs that you read and then you consume and put on graphics. So that can be one option. But yeah, the idea is that you know easily if it's a problem with the worker node, or if it's something on the pod, or if it's something on the scheduler that cannot schedule because taints or anti-affinity or affinity configuration. Yeah. And for you with Mongo, what you're using to monitor the Kubernetes level?
Our Kubernetes is managed by
That yeah, well, that's actually in the black and white version. That's available on the event section at the bottom. But we collect it and make it and persist it, because that's another thing. When you lose a pod, if the pod information is not persistent elsewhere, you lose it. So it's super hard for do postmortems, for example, or figure it out. Yeah.
So will this help for you? Yeah, so this is the metrics captured. You have a lot of stuff like CPU, memory, network. Let me do it the simple one. The network traffic, the disk space, a lot of stuff. My usage. And yep.
And that's going to be shipped with PMM?
No, you need to install it. Okay. Right now we haven't.
It will. It will.
For now, all you need to do is it's a very simple command. Like if you see like helm list -a, all I've done is installed node exporter, which comes with a simple helm chart. It's like one-liner command. If you just do a one-liner, it will install node exporter for you. And the second easy step is importing the dashboard. You just need to copy the clip ID. So you can get all the things. You have pretty much any metrics you want. Like probably you will get bored of seeing this metrics. You see here, right? Memory anonymous, huge page size. A lot. I'm getting tired of scrolling this down. So you can imagine so many metrics here. A lot of stuff. Yep. A lot of metrics. You might pretty much have it for anything like on-prem, cloud, any combination.
Anything that you can in /procs and /sys.
Yeah.
You can get it from node exporter.
Yeah. So again, a lot of things can be captured. You can also see how the pods are, like which namespace, allocation per pod and all those things. So yeah, PMM can do a lot of things for you. So please feel to try it out. And we saw the community. So I don't know how good we are in time. So we have time, right? Or
Is there a minimum PMM version needed?
no. But we always
Ours was the point of I need to look at upgrades. And I'm just wondering,
I think this.
What version are you using now?
I don't know it off the top of my head. I do know. Can you get memory statistics very well because it isn't container aware just yet? I know that's.
Yeah. If it's older than 237, probably, there's no distinction with what is a C group metric or just from the underlying host.
But I am very interested in pod statistics.
Right.
So I'll need at least another newer version.
So for this, we have modified all the custom resources. So I won't get into the details. If anyone's interested, probably we can sync up. So thank you, everyone. If there are any questions, please feel free to reach out to us. Thank you.